Hi, this is Mr. Anderson, and in front of you, you see an image of two glass jars holding water. And what we're going to do today is investigate molecule motion. So we know that water is made up of the compound H2O. And the problem with it is that we can't see it, right? It's invisible to our eyes. So today, we're going to use some dye. We're going to put it in these jars, and we're going to use it to see the motion of the molecules that make up water. And in fact, it's this motion of molecules that actually creates the temperature. So we can see the jar on the left, your screen, is 68.5 degrees Fahrenheit. And the jar on the right is reading 143, oh, it changed, 144.1. And it's changing because of that molecule motion. So, let's check this out. I'm going to put a drop of dye in each, and then I'm going to quickly start my timer. And we're going to see how long it takes for the dye to move completely through each jar. Alright, so there's about a 1 second delay there between the jars, but it won't end up making a difference in the end. Alright, so I'm going to let the video go for a minute, and we're going to look and observe at how fast the dye is moving. It looks like we can already see a difference in how fast the dye is moving through one jar from the other. So we can clearly see molecular motion is happening, and there seems to be a big difference between one jar and the other. All right, so we're going to do a little time lapse as we wait for the dye to spread completely through the jar by the motion of the molecules that make up the liquid. All right, so we just saw 2 minutes go by, and we can see that in the right jar, the liquid or the dye has been moved through most of the liquid. There's a little space right down here at the end, at the bottom, where it hasn't completely mixed yet. All right, so we just passed the 5-minute mark, and I want to point out that the dye in the jar on the right at 131.7 degrees right now has completely spread throughout the entire jar. And on the left, our jar that's at 68.5 degrees, we can clearly see that the dye is still spreading, but it has not moved throughout the container yet. All right, so we're back. We're going on 10 minutes, and you can see that the jar on the left, currently at 68.5 degrees, is still in the process of moving the dye throughout the jar. Alright, so I've set the camera up to be a little different angle so we could get a close-up of the jar with 68.5 degrees water in it. And so just after the 12-minute mark here, we can see that there's still a lot of open space in the jar as the particles, as the dye is moving. Okay, so we're coming up on the 16-minute mark here. You know, 1 second, try and move our camera in a little bit more. There we go. And now we can see that the dye is still moving through the jar. It has not completely mixed yet. We can see there's some open areas. So we'll continue to monitor. Okay, so we're just hitting the 28-minute mark, and I'm holding the camera now so we can try and do a real close-up of the jar. And as we see, there are still spaces in the jar that are open from the dye. So while it's spread quite a bit, it's not completely there yet. Okay, we're coming up on 33 minutes, and we can see that the dye is definitely more prevalent in some areas than others, but it has spread completely throughout the jar. So I think at this point we can call it and say the water at 68.5 degrees took 33 minutes to spread completely through the jar.